This lesson is about writing algebraic expressions. Now remember, an algebraic expression is an expression that's made up of variables and operation symbols and possibly constants or numbers. Now, we got to remember the terminology that we use whenever we add, subtract, multiply, and divide. In other words, sometimes they'll give us an expression or they'll give us an example or a situation, and we have to know what that situation calls us to do. Does it call us to add or to subtract or to multiply or divide? So when we see words like plus and the sum of and increased by or more than, we typically know that we're supposed to do addition. With subtraction, we see words like minus, difference, subtracted from, less than, or decreased by. With multiplication, we see words like times or the product of. In some special situations, we have things like twice a number, which means 2 times that number, or a number doubled, which means 2 times that number. With division, you see words like quotient, divided by, and again, in some special cases, you may say half of a number, which means you're dividing by 2, or multiplying by 1/2, or a number halved means you're dividing by 2 as well. So here are some examples of some different expressions that we are to write now in symbolic form. A number D plus 55. Well, they're telling us that the number is D, that's the variable, and plus means to add, so I would write this expression D plus 55. Remember, right now we don't know what D equals. That's why we have to be able to write these expressions like this and solve them for different situations. And I'll show some situations towards the end. 28 more than a number n. Well, that means I have the number n, and then I'm going to do 28 more than that, which is telling me that I add n plus 28 more. The sum of a number and 2. Sum is my key word. This time it didn't tell me what the variable was called. I can call the variable n or any other letter that I want to call it. And 2, the sum of, so it's n plus 2. Down here we have a number minus 7, so I have some number, let's call it x. X minus 7. The difference of a number y and 8. Difference tells me I want to subtract, so I do y minus 8. I've got to be real careful about the order here because when I flip-flop subtraction, I don't get the same value. So it says the difference of a number y and 8, so it needs to be y minus 8. If it said a difference of a number 8 and y, I would have to write it the other way. A number m decreased by 12. Again, m comes first and then I decrease or I subtract 12 from it. Okay, 4 times a number r means 4 times r. Now, we don't really write 4 times r like this anymore. We just write it next to the variable, and that's okay. In fact, I want you to get in the habit of writing it that way. The product of 9 and a number v, we're doing 9 times v, or 9v. Twice the number j means 2 times j. The quotient of a number b and 12 means I'm doing b divided by 12, which I might also write as b divided by 12. You kind of have to be careful when you use the variable b because you don't want it to look like a 6. A number m divided by 6. So I have m divided by 6 or m divided by 6. But be really cautious because this one's different. 15 divided by a number n. This time I have 15 divided by n, or 15 divided by n. Remember, division is not commutative, so it matters the order that you write these in, just like it matters with subtraction. Now, there can also be more than one operation in an algebraic expression, such as 6 more than twice a number s. Well, this is telling me that I have twice a number s, or 2 times s, and then 6 more than that. So I'd write that as 2s plus 6. 2 times s plus 6. Here's another one. The product of a number j and 6 decreased by 7. Well, I'm going to find the product of j and 6 first. And remember, I want to write that 6j, not j6. That's like bingo or battleship. We put the number in front of the variable, but that means to multiply. So I have the product of 6 and j, and then it is decreased by 7. Keyword there, decrease, which means I'm subtracting 7 from that product. Now here's a couple of examples of real-life situations where you might need to use an algebraic expression. Let's say it's family night at the movies. This is a fairly simple one-step algebraic expression. It's $8 per person at the movies. Depending on how many people go will depend on the price that you have to pay. If only one person goes to family night at the movies, then that costs $8. But if 3 people go, 8 times 3 is 24. So you use the expression 8 times P. Here's one that requires more than one operation. Let's say you're having a skating party. And here's the deal. It costs $4 per person to skate, but then you have to pay $50 to rent the party room. So even if you go in there and nobody skates, it still costs you $50. And then $4 for every person that skates. So if one person skates, that would be 4 times 1 plus $50. And that would be a total of $54 for the skate party. But if 10 people skate, it would be 4 times 10 plus the $50. 4 times 10 is 40. 40 plus 50 is 90. So then it becomes $90 if you have 10 people skate. So this varies or changes, and that's why we have to write an algebraic expression containing a variable. Because you don't know how many people are going to show up to the party to skate, and you don't know how many people that show up actually like the skating. How about when we have cookies for classmates? I think this is a good idea. Let's say there are 25 students in the class, and you need to know how many cookies each student gets. Well, it depends on how many cookies that the person brings. You would do the number of cookies divided by 25 to see how many cookies each person got. And if this number was not evenly divisible by 25, it wouldn't be fair that only some people got cookies and some people got fewer cookies than others. So if this number is divisible by 25, then it depends. If you bring 25 cookies, 25 divided by 25, everybody gets 1 cookie. If you bring 50 cookies, 50 divided by 25, everybody gets 2 cookies. 75 cookies, divide by 25, everyone gets 3 cookies. Now we're talking. That's how you write algebraic expressions.